Everyone, and welcome to another video on physics. Sorry, guys, down. Ouch. Sorry. Welcome to another video of Mr. Frank Edu Solutions. And in today's video, we're going to actually trying to looking at physics. And then our first class we looked at the various equations of motion. Now we're going to actually look at how do we apply those equations. It's not just knowing them, like the issue is at their application. I'm going to try and be drafting out some questions. I'm going to try and apply the various equations of motion. So let's look at today the calculation class. So calculation class, and let's look at number one. I'm going to try and pick a question from my head that is going to reflect what we're going to try to do. Okay, let me pick the simplest of all I can remember. Okay, a car moving at a velocity, at an initial velocity of 30 meters per second accelerates, okay, moves with an acceleration of 2 meters per second square in 5 seconds. Find the final velocity. Now, but before we go further, I'd like to state all the equations of motion we derived. First, that V equals U plus AT, and that S equals UT plus half AT squared, and V squared equals U squared plus 3. So these are the various formulas we're able to derive. We're going to try and apply them. So let's look at this one. So solution. The first step is solving a physics question, any question irrespective of the topic, is to list out your parameters, because this gives you back. Okay? Parameters given. Parameters given. We have initial velocity U. I'm not going to write in the initial velocity U is 30 meters per second. That was the initial velocity. With acceleration, acceleration 2 equals 2 meters per second squared. Okay, and the time t is 5 seconds. This is a very simple question, and so if you find the velocity v. So all you have to do is to come to the formulas, check this one has v, has u, has a, but s we don't have s because so this one has s, has u, has no, can use that, and this final one has v, that's u, that's a, and that's t, which is everything we need to solve. So let's solve it, and you have to use your b equals, so let's use form 1, from equation 1, b equals u plus 18. That's the first equation of motion. So we're trying to find v. We have v equals what's u? 30 plus what's a? 2, and what's t? 5. So we have v equals 30 plus 2 times 5 is 10. So our v equals 40 meters per second. So this is the final velocity for a car which has an initial velocity of 30 meters per second and an acceleration of 2 meters per second in 5 seconds. So this is very simple. It's as simple as this. I don't believe that there's any equation or motion question that should trouble any student. I don't believe there's any that should raise there. If there is, I think I have an idea of a perfectly suitable one that might trouble many students. So I'm going to try and highlight that one right now. Okay. But I don't think any of these questions are actually difficult. Sometimes you have to carve out 1 or 2 things, but they're actually very simple. Sometimes you have to apply it to a thing. Now let's look at this question. A boy running a relay race, running a race with an initial velocity. So it's something because I'm not typical, so but I'm trying to get them from my head so that they can rhyme with the formula I'm trying to use. The initial velocity of 60 to 30 meters per second, and an acceleration of 3 meters per second square. Stop. Find the distance covered by the boy between the second and third seconds. This is a question I know that many students may actually find difficult. So, if a ball moving at an initial velocity of 30 meters per second and acceleration of 3 meters per second square, find the distance covered by the ball between the second and third seconds. So, many students will find it actually quite difficult, but this is actually not difficult. Solution. There are two ways of going about this question, and I will go through the two ways in a bit. So let's look at what we have. So we have u 30 meters per second. We have we have t between second and third. Okay, what else do we have? We have a 3 meters per second square. And then we are supposed to find s, which is distance s. So there are two ways of solving this question. First, I can find the distance how many distance he has. The distance is covered in the second as of the second, and the distance is covered in the third second, and then subtract them and get what the mean distance is covered between second and third. So which is this way, s equals ut plus half at squared. So this time we're taking 2 first, so s equals 30 times 3 plus 1 over 2 times 3 times. Okay, I would like to change my seconds to 2, my solution to 2. Not for anything, but just for easy calculation, because I'm going to be using a calculator. So for easy calculation, I want to like to use 2, and then time will be 2 seconds. So you get to be s equals, let's change it to the s. The time, we're doing the 2 first. So you have 60 plus 2 here, 1, 2 here, 1. So you have, so now I change it to 2, so I can easily cancel out. You have 60 plus 4. So the distance covered as of the second is 64 meters. Okay, because this delta is 260. 2 square is 64 meters. And then as of the third second, you have s equals 30 times 3 plus half times 2 times 3 squared. And then you have x equals 90 plus these and these are off, plus 9. So s is 99 meters. So we have that the distance covered between second and third second is 99 meters minus 64 meters, which gives us 35 meters. Use this 5 meters. So in this way we have been able to deal with that question. And the second method I feel we can solve this by doing this. From s equals ut plus half at squared. Okay, so I'm going to try and be multiplying it. So I have s equals to u is 30 and t, since it changed between second and third, I'm doing 3 minus 2. Okay, plus because so it should be between second and third. So 3 minus 2 first plus half a, which is times 2 times, you're going to be having, watch, this t squared, so it's 3 squared minus 2 squared. So this is another method we can apply. All you have to do is, when you have t, you take that, you change into 3 minus 2, and you have 2 squared, change into 2 squared, 3 squared minus 2 squared. So if you do that, you have that s will now be 30, this one, plus half, okay, so just see this and this goes off. So what we're going to do is 3 squared minus 2 squared. We're going to have s equals 30 plus 9 minus 4. We give us that s equals 30 plus 5. Is the s is 35 beta. So whether you use the first method or the second method, you still actually arrive at the same answer. So this is the part that actually gets a little bit tricky. Even for a lot of students in the university, if you present them this question, they may struggle. But I believe any student who's watching this video should be able to trash this question comfortably without any stress. And to portray the final method, I would like us to look at the question. Okay, like I said, this method are very simple to apply. All you have to do is to get the parameters given. Your ability to interpret the question is very, very important. Very important. Interpretation of question is important. The third one says, okay, calculate the final velocity of a chalk moving, or a chalk starting from rest with an acceleration of, let's say 2, okay, let's stick to 2, or let's say 5, let's go high, 5 meters per second square at a distance of 50 meters. So they say the body started from rest and to obtain acceleration of 5 meters per second square. So we find calculate the final velocity when it's at a distance of 50 meters. So solution, let's do our parameters. Final velocity was so I'm looking for. Started from rest. Now that's ready. I actually added this from rest so as to bring cheap this in. Whenever we hear that something started from rest, it means that the initial velocity u was 0 meters per second. It was normal. So that's one part we need to understand, because it comes out a lot in many questions from rest. Not sure to say it means that u was 0. And then acceleration 5 meters per second. And then distance s is 50 meters. Okay, to calculate this question, we can also match it with the third equation, which is v squared plus u squared plus 2s. So what's v squared? We don't know. So v squared equals, I like to change this to make here 2 for easy solving. Let's make here 2 for easy solving. So if you have this way, equals u squared is 0 squared plus 2 times 2 times 5 stick, let me stick to 25 here. Most of these questions are from my head, so they're probably not perfect squares, so I'm trying to make it a perfect square so we can easily solve. So we have 2 times 2 times 25. we have v squared equals 0 plus 2 times 2 is 4 times 25. So v squared equals 100. So we take square root of both sides. Take square root. We take the square root. V squared square root of 100. So v is not 10 meter per second. So we have been able to apply the first, second, and third equation of motion. With this, I believe we have come to the end of today's video on the calculations of the various equations of motion. Please always remember to subscribe to our channel and to like our video. Thank you so much.